Hello, my name is Isaac Zulani, my name is Sham. Me and my fellow groupmates from Group 1 will be discussing our report on statistics of vehicle fuel consumption per 100 kilometers, which is set A. Now, to start, I would like to talk about the data description. Now, the purpose of this study is to learn how to use the SPSS for data collection, statistical analysis, graphical representation, and descriptive statistics to describe the data set that's given. Now, the sample data are summarized using a descriptive status. Based on the dataset given, which is dataset A, there is a total of 392 observations with a dataset of vehicle fuel consumption per 100 kilometers. Now, on the table above, we can see that the data collection includes the liter per 100, kpl, cylinder, horsepower, weight, and brand. The scale of measurements is also included, in which all of the scale of measurements is scale, while the cylinder and the brand is nominal. The type of variables is also included, in which all said variables is numeric except for brand, which is a string variable. Now we move on to 2.0, sampling and record categorical data. Now, sampling is the process of selecting a few people or things for an internal study that each individually or objectively represent a sample of the intended community. In dataset A, there is a total of 369 observations, in which we have recorded and categorized into 150 observations. The dataset has been characterized in a collection of facts such as mean, median, mode, and standard deviation, and variance and quartile. Now, as we can see on the table above, there are liter per 100, kpl, cylinders, horsepower, weight, and brand. Now, each of these have their own mean, standard deviation, median, mode, variance, range, the minimum, maximum, their summary, and their quartile, from ranging quartile 1 to quartile 3.
Hello, my name is Muhammad Amir Shazwan bin Rosli. My metric number is A21A2624. 3.0 Numerical Descriptive Measures. The first of central measure tendency, which is the mean. The formula of mean is mean equal to total of fx divided by n. So, mean for kpl is 16.49. Next, the second of central measure tendency is the median. The formula of median is Lm plus n divided by 2 minus total of Fm minus 1 divided by Fm multiplied by C. So, the median of kpl is 214.63. The last of central measure tendency is the mode. The formula of mode is Lm plus change 1 divided by change 1 plus change 2 multiplied by C. So the mode of kpl is 52.33. Then I'm going to explain the second measure, which is measure of position. They have divided by two parts, which is first quartile and third quartile. The formula for the first quartile is LQ1 plus n divided by 4 minus f divided by FQ1 multiplied by C. And the first quartile for kpl is 113.08. While the formula of third quartile is LQ3 plus 3n divided by 4 minus f divided by FQ3 multiplied by C. And the third quartile for kpl is 469.10. So the interquartile range of third quartile and first quartile is 356.02. The last measure is measure of variance. The formula of variance is s power of 2 equal 1 divided by 150 minus 1 multiplied total of fx power by 2 minus total fx in bracket and the power of 2 divided by n. So, the variance for kpl is 110,210,272.6. The formula of standard deviation is s equal to source of power s, the power of 2. And standard deviation for kpl is 10,498.11. Next, I will explain about horsepower. Measure, which is the mean is 1.36 and the median is 1.35 and the mode is 1.38. While the first quartile of the horsepower is 1.03 and the third quartile is 1.55. while the interquartile range is 0.552, and the last is variance of the horsepower is 0.138, and the standard deviation of the horsepower is 0.371. Next, I will explain about weight measure, which is the mean is 3.84, the median is 3.33, and the mode is 2.84, while the first quartile of the weight is 2.89, and the third quartile is 3.65, while the interquartile range is 0.76, and the last is variance of the weight is 0.3344, and the standard deviation of the weight is 0.577.
Assalamualaikum and hi, my name is Istika Sarah Zulaika and my matrix number is 818251. Okay, for the categorical data graph, we have taken brand and cylinders as a subject. As displayed in the pie chart, BMW has the most frequency with 44 frequency or equal to 29.3%, while Citroën is the very least, which is only 2 cars, 1.3%. Ford and Honda has the same amount of cars, which is 36 cars. For the cylinders, the number of cylinders 8 have 97 frequency with the percentage of 64.7, which is the highest, while the number of cylinders 5 is the least with only 1 frequency or 0.7%. Then the number of cylinders of 4 and 6 recorded 5 and 47 frequency respectively. Next, we will discuss about the numerical data graph. We have taken 8 class intervals of each of them. The first one is KPL. At the midpoint of 10.36, the graph started to increase and reached the highest frequency at 45. And then at midpoint 15.8, it started to drop the frequency of 2 drastically. Next is the horsepower. As you can see in the histogram, midpoint of 1.39 shows the highest frequency, which is 46, and midpoint of 2.02 decreased the frequency to 6. The last one is weight. At the midpoint of 3.2, the graph shows the highest frequency, which is 28. And then they decrease to the frequency to 6 at midpoint 5.03. All the graph has the same shape, which is histogram graph and line graph with bell shape.
Hello, my name is Nurul Ain binti Khairuddin and my metric number is A21A2947. I will continue about the graph 5.1. Graph 5.1 shows about the numerical descriptive measures. The data of mean, median, and mode shows the difference result because the SPSS cannot read the data accurately. All the data used above is already recorded. There are 3 types of measure, which is measure of central tendency, measure of position, and the last one is the measure of variation. Next is the comparison, graphical representation between manual and SPSS for KPL, horsepower, and weight. So I will continue 5.2, which is hypothesis testing. There are various categories under a field such as KPL, horsepower, and weight. The DF for all the categories remain unchanged at 391. The test for KPL group is 59.475, while the mean difference is 23.4459, and the confidence interval of the difference for lower is 22.671 and upper is 24.221. For the horsepower group, the t-test is 57.737, while the mean difference is 1.00469, and the confidence interval of the difference for lower is 1.0065, and for upper is 1.0829. For the weight group, the t-test is 69.405, while the mean difference is 2.977584, and the confidence interval of the difference for lower is 2.89324, and for upper is 3.06193. T-test for P1 is pairing about KPL and horsepower. which is step 1. H origin is H1 minus H2 equal to 0. H1 is H1 minus H2 not same to 0. Step 2. Significant level is equal 0.05. Step 3. Using t-test. The answer for t for this pair 1 is t equal 56. For the step 4 is decision rule. We reject HO if T more than TADF, critical region. T, which is T 0.05149, equal to 1.660. Step 5, making decision rule. Since T smaller than TADF, which is 10.343, small than 1.660. So, we reject H origin. ANOVA, step 1, is state hypothesis. H origin equal to H1, equal to H2, and equal to H3. HA equal to the two variables means are not the same. Step 2, state significance level, denoted by A. A equal to 0.05. Step 4, decision rule. We reject H origin if F more than FA, V1, V2, critical region, 6.39. Step 5, making decision. We reject H origin since F for KPL equal to 0.970, small than 6.39, and horsepower equal to 0.023, small than 6.39. Therefore, we reject null hypothesis. H origin more than have 0.05742, which is 228.749, more than 3.785.4.
Assalamualaikum, my name is Muhammad Shafiq Ashrabi Ismail. Today I will discuss 5.3 explanation. The value of R between KPL and horsepower negative 0.707, in which show the strong negative correlation. R value KPL and weight is negative 0.650, in which show the strong negative correlation. The value R between horsepower and weight is 0.716, which is show the strong positive correlation. Next, 5.4. The diagram show the confidence interval for KPL, horsepower and weight. Next, 5.5. Prediction modeling. Figure above show the association between KPL, horsepower and weight. There is a high level association between KPL and horsepower, KPL and weight, horsepower and weight. Among the independent variable, there is high level association between KPL and horsepower. Figure correlation show KPL correlates highly and horsepower and weight. There is no significant correlation between KPL with horsepower and weight. Horsepower correlate highly with KPL and weight. There are no significant correlation between horsepower and with KPL and weight. Weight correlate highly and with KPL and horsepower. There are no significant between weight with KPL and horsepower. Next, the diagram show the model summary, ANOVA, and confidence with calculation. Conclusion. The data provided in set A show the liter per 100 KPL, cylinder, horsepower, weight and brand. SPSS statistic is an IBM statistical software institute for data management, advanced analytic, multivariate analysis, business intelligence and criminal investigation. In sampling data and recording categorical data, we need to use IBM SPSS statistic to randomly record 150 observations. We both use manual calculation and the SPSS software to create a hypothesis using t-test and ANOVA. We have come to a conclusion that it is better to use both manually and SPSS to get a more accurate data sample.